Welcome back to the final video in this series. With this video we are looking at final tweaks and interactions we can add into our scene to give it some more functionality. In the last video we looked at taking our original GLSL file, putting it into a new Synesthesia scene and making it compatible and looking at some audio activity uniforms in Synesthesia. Let's start with adding an animating rotation. Looking at our Synesthesia GLSL file, at the top above renderMain void, we're going to write the following code which we can find on the Book of Shaders website under matrices. So above our vec4 renderMain, giving us a few line breaks, we're going to write mat2 to create a matrice, so a way of transforming our shader. We're going to call this rotate. So we're making this a rotate function, and then brackets. Inside the brackets we'll write float angle. This means we're making a function called rotate, and it's going to require a number as its input that we can use back inside the curly brackets of our shader. After the float angle inside the brackets, we're going to jump out and add curly brackets. Inside the curly brackets, we're going to give ourselves a line break, and then we're going to write the following line of code. So we'll write return mat2 brackets. We'll then write inside the brackets cos, open and close brackets, and inside that we'll write angle. After the close brackets for angle, we'll add a comma and then space, minus sin, and again adding brackets back in and writing the word angle. After angle, another comma, then sin, followed by, you've guessed it, brackets and angle. Then one final value after the angle, one final comma, cos, and inside those brackets again, angle. The line ends with two closed brackets, which is already made for us, but then we need to finish it off with that semicolon. So the bulk of code we've just written should be mat2 rotate, open and close brackets, and inside that float angle, open curly bracket, and then on a new line return mat2 open bracket cos, inside brackets angle, comma, minus sin, inside brackets angle, comma, sin, inside brackets, comma, cos, inside brackets angle, and then close brackets and a semicolon, and then below that ending with a close curly bracket. Whilst it's not important to understand how this particular function is working, that privilege will come with time and experience. All we need to know for now is that we are creating a 2D rotation matrice function which will take a float value to be the angle of rotation. So essentially, further inside our code we can declare a function called rotate that will follow open and close brackets, and inside that there'll be a value that we can either use from 0 to 360 for a full rotation. To then rotate our scene, we need to write an additional line of code inside the renderMain void and above anything that we want to rotate. For example, as we want to rotate the box, we need to write above where we begin drawing the box by declaring it as a vec3 in brackets 1. So above that, we'll add a few line breaks, but write this below the vec2 st equals underscore uv because that is our coordinates and we don't want to mess around with those. We will write st equals rotate, open and close brackets, and inside the brackets we'll put a 0 for now, so we're not doing any rotation. But after the brackets we'll do multiply st semicolon. So what we're doing here is we're saying our original coordinates, we're going to rotate them and we'll add them back on by using a multiply function. So essentially we're rotating our coordinates here. The O represents the angle, so I can replace this value with, let's say, another audio uniform. This time I'm going to use sin underscore BPM twitcher, which means we'll rotate our scene to the tempo of the music. We can control how much we rotate on each beat with some basic math. I'm going to divide the twitcher by 4 to slow it down a bit. This will leave me with sin_BPM twitcher /4 to divide by 4. Okay, if we save and reload the scene in Synesthesia. However, you'll notice that our box doesn't rotate around the center. Instead, it's rotating around the origin point of 0, 0, which happens to be the bottom left corner. To fix this, we just need to temporarily move our coordinate space out of the corner into the center. A line above st = rotate, we'll write st minus equals vec2, open and close brackets, and inside of that we'll put 0.5, ending with a semicolon. So this will move our entire scene up and to the right by half of the image's resolution. However, this will move our box off screen, so after the st = rotate, we need to fix the coordinate space back to the bottom left corner by writing the following line. st plus equals vec2, open and close brackets, and inside of that again we'll put 0.5, ending with a semicolon. Save and reload, and there we have our scene rotating in time with the music in the center of our viewer. One of the coolest things with Synesthesia is the ability to merge your scene with video, whether that be video from a webcam or stream input, or a video file. In order to allow our scene to composite with a video input, we need to add some more code to our scene. Video comes into Synesthesia as a vec4, so first we need to convert our scene into a vec4 from a vec3. At the bottom, just before our return vec4 in brackets color, 1, we'll add a few line breaks, and then we will write vec4 final to create a vec4. I'm going to call this final so we know this will be the final output for this scene. Then we'll write equals vec4, open and close brackets, and inside that we'll write color, 1, ending with a semicolon. So we're creating a vec4 called final, which is using the color information from the vec3 above, and the additional one gives us all the data we need to construct the vec4, leaving us with the line vec4 final equals vec4, and then in brackets color, 1, ending with that semicolon. In order to check this is working, we need to replace the return vec4 color, 1, with just vec4, and then inside the brackets we'll replace it with just final. We don't need to put 1 after final because we are actually taking the information from the vec4 we declared above. Save and reload, and we should have no problems inside Synesthesia. So we've converted our scene into a vec4, now we can add our video input. After our vec4 final equals vec4 color, 1 line, we'll add a few line breaks, and now we need to write the following code. If open brackets underscore exists, open brackets sin underscore user image, we'll then jump outside of those two close brackets, followed by an open and close curly bracket, and inside of those we'll add a new line break, and then we'll write final plus equals open and close brackets, and inside that we'll write underscore load user image. Then an empty open and close bracket. We move a space on. We want to leave those brackets closed with nothing inside, but we still want to remain inside the wider brackets. We're then going to write multiply, so use asterisk and 1.0. End that line after the last bracket with a semicolon. And now we have a function that will check if we have a video input, and if we do, we'll add that video as an input on top of our final Vec4. Where we have the final plus equals, we can change that to be divide, subtract and multiply to achieve different compositing results. For now, we can just add the video on top. The multiply 1.0 is something I like to add. So I like to multiply the video with another value to give it a bit more brightness and contrast to the video. Feel free to remove the multiply 1 or change the value to suit. At this point, we'll save and reload. Now if we navigate to the control panel that looks like 3 sliders and scroll down to the media section, you can either click on the webcam input or you can add a video to the Syn videos folder. So I've got some videos added. Some of these I've made myself, some of these I've bought from stock websites online. I'm going to use my hot dog animation I made with After Effects. And now we can see our video is being composited into our scene and our box is added on top. If I go back to my GLSL and replace that final addition equals with multiply equals, save and reload, my hot dog will only appear whenever the video overlaps with the box. So the video looks like it's contained inside the box. Let's revert the multiply back to addition. Most scenes in Synesthesia have additional controls, so accessing the control panel of our scene by scrolling back up, we can see Synesthesia creates a slider control under the Scenes Control tab. Controls are created by editing the scene's JSON file, and then we link that to a value within the scene's GLSL file. Let's look at editing the slider 1 control to control a function inside our scene. If we navigate back to our scene library, then click on our new scene, edit scene with the pencil icon to find our files. We're already editing the main.glsl file. This time we'll want to open up the scene.json file as well. If we open the scene.json file in Atom, we can see a header called controls. Then within the square brackets, you can add controls. By default, Synesthesia always creates a slider called slider 1. A default value is the value we want to reset to each time we load the shader. Description allows us to write a reminder for when we hover over the control in Synesthesia. Min and max lets us set specific minimum and maximum values. Name is the name of that slider and the name of the value we will reference in our GLSL. We can rename this to be more relevant, so I will rename mine from slider 1 to amount. Save. Lastly, we have different types of controls. I will leave mine as a slider, although the Synesthesia documentation covers different types of controls. Save this file, and then moving back over to our main.glsl file. Scrolling back up, I'm going to replace the 4 after the syn_bpm twitcher with amount. And then save this file and reload in Synesthesia. Now our slider will be titled amount, and when we operate the slider, it'll send a value between our minimum and maximum values to our GLSL file. So here we are editing the number that's dividing our syn_bpm twitcher. If we remember our default value that we used originally was 4, I'm going to jump back to my JSON file. I'm going to change the default value from 0.2 to be 4. I'll leave the minimum at 0, but change the maximum to 10. So I can dynamically control how much my scene is rotating to the tempo of the music. Remaining in the JSON file, let's tidy up our scene and make it look a bit more professional. So further down in the JSON file is where we can edit the metadata of the scene, essentially allowing us to rename our scene and add an author should we wish to share this scene with others. Credit can be our name or artist name, so my credit will just be my name. and I'm going to write a simple description. You may also wish to specify a height and width, such as if we're projecting or displaying to a device that requires a certain resolution. Image path points to the image in the folder that we'll use as the thumbnail preview. Synesthesia creates a default one for you, but we'll change this shortly to match our scene. Lastly, the title is the name of the scene, so let's name our scene to something fitting. I'll write boxes and then save my JSON file. If you then jump back to Synesthesia, reload your file, go into the scenes library and click refresh library at the top, your scene's name and author name should now appear. The final thing to take care of is the thumbnail. What we'll do is we'll run our scene reacting to some music, and as it's working, I will screenshot the preview window. We'll then save the screenshot and move it into the folder that contains my main.glsl and my scene.json file, and I'll rename the image to boxes.png. If you're on Windows, you can save your screenshot directly by going to your C drive. Then in your C drive, you should find the folder Synesthesia Scenes. Then inside there, find the folder. So for us, it will be new_scene. And inside of that, I'll save it as boxes.png. In order to get Synesthesia to use this image as the thumbnail, we need to open up the JSON file again for the final time. Where it says image path, we need to replace the current image title from new_scene.png to boxes.png. Save the JSON file, and if I click refresh library, I should now have my thumbnail preview for my Synesthesia scene. We can also take it one step further. If we look in the folder where our GLSL and JSON files are located, we'll see that it's inside a folder called new_scene.synscene. To make things easier for myself in the future, I'm going to rename this folder, and if you do, make sure it ends with .synscene. So I'm going to rename it to boxes.synscene. There we go. From the following videos, we've learned how to do some basic coding in GLSL, created a new scene in Synesthesia and made sure our code runs in there with no issues. We then looked at adding audio reactivity, integrated video and controls, and lastly looked at tidying up our scene package to make it look more professional. At this point, it's time to check over Shader Toy to get inspired, read the book of shaders to improve your GLSL coding skill, and utilize the Synesthesia shader documentation to help you achieve your visuals. Thank you for watching this tutorial series. If you enjoyed it and wish to see more content like this on my channel, consider liking and subscribing to my channel. Thanks again, and I hope to see you again in the future.